Okay, so this is 2.1, 11a. Find the derivative of each function. So we are finding the derivative from the definition of the derivative, okay? And the definition is those limits ones. So we can use whichever limit function we want. I think we most of us kind of like this h approaches 0, 1. So if it says find the derivative of each function and that's it, that means we're looking for an expression. We're not looking for an actual value because they would give us at a equals 2 or at x equals 5 or something like that. So it's just the function itself. So we're going to go root 2 and we're going to go x plus h because we're just going to use x instead of a because we'd have to change x to a anyways later. So we'll just do x plus h minus 1 minus root 2x minus 1 all over h. And so the issue that we have here is we have this h underneath the radical here, and I want to try and get that out, right? And so we're going to we need to rationalize the numerator. We need to get this h out of there, so we have to get rid of the root if we can. So we're going to try and turn this into a difference of squares. So we're going to multiply both top and bottom by root 2 times x plus h minus 1, and then plus root 2x minus 1. Okay, so top and bottom. I'm going to double that here, 2x plus h minus 1. Okay. So in doing this, obviously we want to get the h out of the radical, so we're going to be expanding and multiplying the top because we want to see that difference of squares. But the bottom, you do not want to expand out. Why? Because we don't want to embroil h in with any of this. We want to actually factor h out, so let's leave it as a factor, right? Yeah. So if we square this top one up here, and I'm going to just maybe multiply that through as well. So we're going to get the square of this, which gets rid of the square root. So that's going to be 2x plus 2h minus 1. And then we're going to be subtracting the square of this one, which is just 2x minus 1. So h is down here, and then this whole thing is still here. So I'm going to go 2x plus 2h minus 1 plus root 2x minus 1. Okay, so when we simplify the top, what do we get? I seem to notice that the 2x and minus 2x, those are gone. And the -1 and the minus -1 are gone. So it looks like I'm just left with 2h on the top. How about that? I've got 2h on top, and then this on the bottom, which, because I have the technology up here, why don't I just try and copy and paste this? Yes. I know it's totally cheating, sorry. Do I care? Nope. Cheater, I know. Look at this. Oh, man, come on. No. Okay, there we go. If he can cheat, you can cheat, is that what you said? Yeah. Yeah, you go ahead and copy and paste. You don't even have your books open, wacko. Let's go. Get your book open. You're getting after me for cheating, and you're just sitting there chilling. Come on. Did you do this one, 11A?
No.
No. Oh, okay. Probably a good idea to do it while I'm doing it. So you just literally copy down what I'm doing.
I have a 4-day weekend.
Oh my goodness, that's a great attitude. Okay, good job. All right, back to the task at hand. H and H are gone. Okay. H and H are gone, so we have 2 on top. We do not have H equaling 0 as a factor on the bottom anymore, so does that solve our problem? Can we now estimate what this limit would be now that these H's are gone? Well, that means this is gone. And that's just it, right? So this term is gone too if we let x equal h. So I have 2 on top, and on the bottom I have root 2x minus 1 plus root 2x minus 1. So I have 2 of these root 2x minus 1s. Is that right? Yeah. So this actually can be simplified even some more. And I've got 1 over root 2x minus 1. How about that?
I missed one step. How did when you cancel the 2H and the 2HO, how did the other H get canceled out?
Okay, so yeah, these got divided out because they're common factors. And then what I did was I basically kind of did two steps at once here where I let h equal 0 now. I'm putting h in. And so that 2h just becomes 2 times 0. Yeah, so I kind of did two steps at once there as I was running out of space on my screen. Okay, so that's the expression for the derivative. So that means that any x value that is possible, okay, that's defined on the interval here, that is in the domain of the function, you just plug that x value in there, and this is the value of the derivative. So if we're looking for the domain here, this 2x minus 1 has to be greater than or equal to 0, right? So let's talk about the domain here. The 2x minus 1 has to be greater than or equal to 0, so 2x has to be greater than or equal to positive 1, x has to be greater than or equal to 1/2, okay? And the domain of the function here, domain of the derivative, I mean. So this is the domain of the function for f of x. And then for f prime of x, remember that's the notation now for the derivative. We have the same, but can x equal 1/2 here?
No, because then it equals 0.
Then we'd have a 0 in the denominator. So guess what? The domain here is x just greater than 1/2, cannot be equal. And we'll assume XER here, so that's all I need for your domain. Okay, so domain here, use those kind of funny brackets, and it's disappearing on me. So that's the domain for the function, domain for the, yeah. So how are we liking that?
Great.
As good as possible? Okay. Any other questions about 11A then? I'll try and get that all up on one screen for you. Okay. For the record, I'm sorry for calling you wacko, but I did. Nobody caught that? Okay, just there you go. Apology accepted.
That was easy.
All right, that was an easy question, wasn't it? Anything else? Yes, no? Good? Oh, yeah. That was all good.
That's
All
gonna be on your
good.
website.
What?
That's gonna be on your
I'm not going to publish this video. Are you kidding me?